Hi, this is Jacob Nash with J&GL, and we're looking at the last lesson of Unit 6, which is Lesson 5, and we're going to look at the angle bisector theorem about similar triangles and proportions of them. So, we learned in the last lesson that what the side splitter theorem can do, where if parallel lines split a triangle, it can make the sides proportionate to each other. Well, there's something else that can do that too, and it's certain angle bisectors. So, we already know what an angle bisector is. If you don't know what it is, you should go back to that unit. I'm not really sure which one it was. So, it doesn't necessarily have to come down at 90-degree angles, but where it comes from, it makes those two angles congruent. So, I know it might look like that's 90-degree angles, but it's not. So, let's just take this for an example, and then let's make this variable j, and let's make this 7. That's not a good 7, because this thing curves when I draw. Don't know why. Let's just make this 4, and let's make this 3. And I do apologize for these later units that there are no review things at the end like there have been, but I just don't really have the time for that in this situation. If you know that this is when the coronavirus has happened, and I don't have a lot of time for things like that anymore. But let's look and see what can happen. Well, since this is an angle bisector, what happens is that these two and those two are going to be proportionate. So let's look and see what we can make. J over 4 equals 7 over 3. Okay. So that's what's true. Why is it true? Just because that this is an angle bisector. You'll have to know what that is. These units pretty much build upon each other. So now when we solve, we can do 3j equals 28. So j is going to be 28 over 3. All right, that's good. Simple enough. Now, let's see a different example. Let's try one when maybe the variable is on the bottom. So let's see what we're going to do. Okay, that's better. Let's try a different one. The triangle could look like this. Doesn't have to be always that way. And this is a different kind of bisector that makes these two lengths seem a lot different. So let's see here what we can do. Let's just say this side length is 14. This is 19. This is x. This is, let's just say 17. Now, you could still put x on the top. We talked about that in the last video, but let's still put it on the bottom anyways. So, what proportion we could create is 14 over 17 is equal to 19 over x. Then we get 14 x equals, that's a messy x. Let's go to the calculator because I don't know that off the top of my head. 323. And let's see if, I don't think so, but let's see if 14 goes out nicely. So it's approximately 23.1. So let's just say x is approximately 23.1. So that's how you would solve that. That's really all that there is to this video. So I hope that this unit seemed easy for you, and check out the next one when we get to it. Thank you for watching.